Right, this slide shows where in our OMHS that we can access the Desmos graphing calculator. If you go into your classroom and you click on content, go down to course information, you will see that the Desmos calculator link is listed. I do encourage you to use Desmos on every single assignment you complete in the class. In this lesson, we're going to talk about inequalities in one variable, and we're going to be talking about compound inequalities. The definition is the solution is any number that makes an inequality statement true. And in the chart below, we have shown definitely the different types of inequalities, the notation, the graph, the interval notation, and the set notation. So in order to graph an inequality, we need to remember that if the inequality is greater or less, this is going to be an open circle. If the inequality is greater than or equal or less than or equal, this is going to be a closed circle. In interval notation, very important that we understand that if a number has an open circle on it, that means the point is not included. And when we write the interval notation, we will be using parentheses. And it depends on where the number is. It may be an open parentheses or it may be a closed. If you have a closed circle, that means the point is included. And when we do the interval notation, we will be using either an open bracket or a closed bracket, which will indicate that the point is included. If I was writing this in interval notation, you can see this is the point A. The arrow that is pointing to the right is always going to be infinity. Likewise, the arrow pointing to the left is going to be negative infinity. All right, when we are writing infinities in interval notation, whether it's infinity or negative infinity, we always are going to use parentheses. All right, parentheses for negative or infinity. All right, when you are solving an inequality, you must always include a graph because the solution is where we're going to get from that graph. So to solve this, I'm going to subtract 6, and I get negative 4x is greater than negative 8. We have to remember that when we divide an inequality by a negative number, we must flip the inequality symbol. So when I solve this, I'm going to get x is less than 2. I am now going to graph, and I'm going to put 2 on my number line. Less than is an open circle, which means 2 is not included, and I'm going to shade to the left. All right, now if I'm writing my solution in interval notation, then I'm going to label my graph. The left arrow is negative infinity, and the number is 2. So my interval is going to be from negative infinity to 2. At this point, I need to understand what notation goes in front. Infinities are always parentheses. And because the circle is open on 2, there will be a parentheses after 2, which lets me know that 2 is not included. The other form is called set notation, and we can write our solution in set notation. It's going to go inside braces. You're going to list the variable that is in your problem, which is x. You're going to draw a straight line down, and that straight line is read as such that, and you place your last step of your solving. X is less than 2. So in set notation, we have x such that x is less than 2. All right, a compound inequality is like a compound sentence. A compound sentence has 2 subjects, 2 verbs. A compound inequality is going to contain 2 inequalities. Okay, you may have an and compound inequality, which is called a conjunction, or you may have an or compound inequality, which is called a disjunction. Now, the most important part about this is the fact that in a conjunction, both statements have to be true statements. So in order for something to be a solution, it has to make both statements true. In a disjunction, it only has to make one of the statements true. Let's look at the graphs, and you have 2 basic problems. First one is an and we will look further at this, but you can tell from the graph that the graph is between 2 points. And that is normally how the graph of a conjunction is going to be. You see the graph for a disjunction. Normally, on a disjunction, you're going to have 2 graphs, and the 2 graphs are going in opposite directions. And we will look at how we write those solutions when we start looking at the examples. But the main thing is, if your graphs are going opposite, normally that is going to represent a disjunction. If the graphs are between 2 points, then that means that it is a conjunction. All right, so we're going to solve this disjunction. This is a disjunction because it has the word or. And we know that the solutions only have to satisfy one of those 2 inequalities. So we are going to subtract 5, divide by negative 2, and when we divide by a negative, we have to flip that inequality symbol, so I get x is less than 1. On the second inequality, I am distributing, so this would become negative 3x plus 9 is less than negative 6. I'm going to subtract 9, and I get negative 3x is less than negative 15. Divide by negative 3, which again, I have to flip that inequality, and I get x is greater than 5. All right, once I have my 2 inequalities solved, I am going to graph. And when I graph this, I'm just going to put a very basic graph, the 2 numbers on the number line. X is less than 1 is an open circle on 1, shade to the left. X is greater than 5 is an open circle on 5 and shade to the right. Now, if we are writing our solution in interval notation, all right, I'm going to label my arrows. This is negative infinity, and this arrow is infinity. So I have 2 intervals from negative infinity to 1 and 5 to infinity. We know infinities are parentheses, These are open circles, so that means behind the 1 I have a parenthesis. In front of the 5 I have a parenthesis. To show that it's these put together, or we are going to use a symbol that is a U, and that means union. So in interval notation, this would say that your solutions are from negative infinity to 1, union 5 to infinity. If I'm doing my solution in set notation, it's going to be braces. I have the variable x such that, and all I do is write the two inequalities in my final solving. I have x is less than 1 or x is greater than 5. All right, which is the correct interval notation for the graph shown? Let's look at that graph. It is between 2 points, and just looking at the graph, I would think that this has been an and problem, an and compound inequality. So to write our interval notation, we have the two numbers, negative 2 to 5. 5 has an open circle, therefore after the 5 it is a parenthesis. Negative 2 has a closed circle, so in front of negative 2 is a bracket, which means that our correct answer would have been answer D. So we need to remember, open circle is parentheses, closed circle is going to be brackets, and infinities, whether it is infinity or negative infinity, it is going to be parentheses. All right, we have an and compound inequality, so we are going to solve. I'm going to add 1, and I get 6 less than or equal to 3x. Divide by 3, and I get 2 is less than or equal to x. Now I'm going to put an extra step in. I'm going to rewrite my final step of solving. And the reason I want to do that is in an inequality, I always want my variable to be on the left-hand side because it makes it easier for graphing purposes. And to do that, all you do is just flip everything. X was on the right, it moves to the left. 2 moves from the left to the right, and we flip the inequality. I'm going to divide by 2, and I get x is less than 6. So we're ready to do our graph. And our graph's going to be a little bit different for an and compound inequality due to the fact that we are looking for a certain area. So greater than or equal to 2 is going to be a closed circle on 2 and everything shaded to the right. When I graph the second part of an and compound inequality, I'm not going to graph it directly on the number line. I'm going to graph it a little bit above. This is x is less than 6, which would be an open circle and shade to the left. In an and, my solution is going to be the part that overlaps. And the part that overlaps is between 2 and 6. So my solution to this problem is going to be a closed circle on 2, an open circle on 6, and everything shaded in between. To do interval notation, I have the numbers 2 and 6. That's what my circles are on. 2 has a closed circle, therefore it is a bracket. 6 is an open, therefore it is a parenthesis. Now in set notation, we know this is where we're going to have braces. We put a variable such that when you have a solution that is between two numbers, this is your part that represents x. So when we write our solution, we're going to have 2, 6, and we know x is between those 2 points. Our inequalities are always going to be less than or equal to. Because it's an open circle on 6, we have x is less than 6. And as you can see, that is what we had in the solving. Because it's a closed circle on 2, this is going to be less than or equal to as our inequality. All right, this question says, based on the given interval, which value would not be a solution? So we know that from -5 to 7, including -5, all of those points are going to be solutions. So I'm just going to graph on the number line where these answers would be. -6 is here, 0 is here, and 6 is here. So if I look at those points on this number line, the point that is not in that shaded area is -6. So my answer would have been -6. Now, I want to ask the question, is 7 a solution? And the answer to that question is no. And the reason it is no is because it has an open circle. Right? And remember that an open circle indicates that the point is not included. All right, we have just an inequality, one variable. This one is not a compound inequality, so we are going to solve. We're going to add 6 to both sides. We have 12 greater than or equal to 3/2 x. When I'm getting rid of a fraction times a variable, I want to do it the easiest way possible. And for me, that is to multiply by what is called the reciprocal. And the reciprocal of a fraction, if you have the fraction 3/2, the reciprocal is going to be 2/3. That means that we are just switching the numerators and denominators. So I'm going to multiply by 2/3. When I do that, I'm going to get 8 is greater than or equal to x. I want to make sure that my x is on the left side, so I'm going to rearrange and get x is less than or equal to 8. Going to graph, and I have 8. Less than or equal to is a closed circle shading to the left. To get my interval, I'm going to label my arrow. This one is pointing to the left, so that is -infinity. So my interval notation would be from -infinity to 8. -infinity is always a parenthesis because it keeps on going forever and ever and ever. Because 8 has a closed circle, we know that is a bracket. So correct answer would have been answer B. All right, we have an OR compound inequality. Going to solve. Divide by 2. And I get x is greater than -1. Second part is distributive. So I get negative 7x plus 28, because a negative times a negative is a positive. Subtract 28. And negative 7x is greater than 21. Divide by negative 7, which means I have to flip that inequality, and I get x is less than negative 3. This is an OR, so my graph should go in opposite directions. So I'm going to put on my number line the two numbers, negative 3 and negative 1. Greater than negative 1 is going to be an open circle, shade to the right. Less than negative 3 is an open circle, shade to the left. And my graph is going in opposite directions. I label my arrows, and I have negative infinity for the left arrow, positive infinity for the right arrow. And because the graphs are two separate graphs, I have to remember that I use that symbol U, which represents union. So my answer is going to be negative infinity, comma, negative 3. Infinity is parentheses. Open circle is parentheses. Union, my second interval is negative 1 to infinity. And open circle means parentheses. Infinity is parentheses. All right, this one we have to determine, first of all, what type of compound inequality it is. And this is an AND compound inequality. We can do this problem a couple of ways. We can break it apart as two separate problems, or we can just solve it as it is. I'm going to go ahead and break it apart. So to break it apart, you are going to take negative 3 is less than or equal to negative 5x plus 12, and negative 5x plus 12 is less than 2. So the middle part of this inequality becomes the left-hand side of the first one and the right-hand side of, or the right-hand side of the first and the left-hand side of the second. So we are going to now solve. Going to subtract 12. I get negative 15 less than or equal to negative 5x. Divide by negative 5, which means that I have to flip that inequality. And I'm going to rewrite my problem where x is on the left side. So I have to rearrange the problem, and I flip the inequality again. So it becomes x is less than or equal to 3. I am now going to subtract 12. I have negative 5x is less than negative 10. Divide by negative 5, which means that I have to flip that inequality, and I get x is greater than 2. So I'm going to graph, and I'm going to put on my number line the number 2 and the number 3. Greater than 2 would be an open circle on 2, shade to the right. Remember, with an AND, we do not graph the next part directly on the number line. We're going to graph it a little above. So it's going to be a closed circle on 3 and everything shaded to the left. Your solution is going to be the overlapping areas, and that is from 2 to 3. So to write our solution in interval notation, my interval is going to be from 2 to 3. 2 has an open circle, so it is a parentheses. 3 has a closed Therefore, it is a bracket.